one of your seniors today, Shailendra Sharma from Bulandshahr.
Oh, interesting. He's
Yeah,
in Brook.
he is currently working with Interactive Brokers. He's an ex-colleague from Sapient for the last 20 plus years. I've known him.
I see. So he taught.
I just asked him. Yeah, that Sandeep used to be my junior.
Yeah. So when I went to college and I met him, he was in third year, I was in first year, and he took me to the computer center and he introduced me to Unix and how to compile code and run it using Unix. I think that was my starting point.
Interesting.
Yeah. Just in case you meet him, tell him that. Yeah.
Yeah.
I had a call with him. So yeah. Yeah. Good. Such a small world.
Yeah.
Okay. So you met him like over a coffee or as an office
No,
trip?
we're close friends actually. We meet at least once a month with families. He
I
used to
see.
be a colleague in Sapient.
Oh, he used to be colleague at Sapient. Okay.
Yeah. Since 2004, I think. So it's been a while, 20 plus.
Yeah.
So we all came together at the same time to US about 15 years back and lived around close by. So.
I see. Such a small world. Then you must be knowing this guy. Mhm. The and he was also there anyway, and Vikrant, he was also
No, I
sitting.
don't know most of his IIT Roorkee friends. It's a
No.
different group.
Vikrant was there in Sapient.
Okay.
So I just met him here. Okay. Anyway, never mind. Perfect. Very small world. And good. All right. Before we start, do you have questions, everyone? Let me open my Jupyter notebook. Okay. I had created a separate repository for this batch, right? It's called Python. This one. Perfect. So yes, where were we? And yeah, I think all of you are now ready to move to the next step. And in the last discussion, I had asked everyone to work on the sorting algorithms. Did anybody take a look at the sorting algorithms? No? Anyone?
No, Sandeep, I'm still trying to catch up on the missed lectures from previously. So.
Okay. And yeah. Okay. Again, I keep getting these questions from everyone. And there's a big misconception around programming, specifically those who don't do programming. And that programming is something that you can get it done from ChatGPT. The answer is no. The very important part of programming is problem solving. Given a particular problem, how would you code it? And so I have been interviewing candidates for one of the companies that I'm consulting for. They need to hire, say, data engineers or data scientists. And I'm realizing that it's completely okay to let people search for the solution. Search for a particular thing. Like, for example, somebody doesn't remember a particular formula. Okay. And let's say I want to ask them, how would you code blue score? Okay. So I'll actually ask them to just look up on internet and look up on internet, see the code, and then explain the code to me. Okay, which is actually pretty difficult. So similarly, like for example, I asked somebody that what was the problem statement? Yeah, do the cosine distance for me with using pen and paper. Do the cosine distance, and I gave her two data points, point 1 and point 2, and find the cosine distance with pen and paper. And I told her that you can use ChatGPT or anything, and but you can't just look for the answer as is. You can only look for like a specific thing, saying what's the formula for cosine distance. Okay, and that actually tells me a lot about the candidate. Okay, if somebody just typing my question as is to the Google search, that's wrong. Instead, I let them, ask me that can they look for this thing on internet or on ChatGPT? Yeah, and then I do that. All right. So keeping that in mind, that what I'm trying to do in this class very clearly is to make sure that everybody gets to do the problem solving. Okay. And yeah. And did anybody else work on the sorting algorithms? Okay. All right. Did anybody know the sorting algorithms already? No? Okay. Never mind.
I tried using my thought and looking at the animation of bubble sort.
Okay. You looked at the animation of bubble sort. Okay.
I'm able to do the bubble sort as well as insertion sort. And
Okay.
yeah, I'm working on merge sort, but I have not completed it.
Okay. Okay. Show me the insertion sort. So everyone, the insertion sort and bubble sort. Okay. The reason I am asking everybody to code it and do it is because coding is all about doing by yourself. Okay. And I might teach you, I might show you good code, bad code. But again, unless and until you code it by yourself, you won't get that confidence. Okay. So I humbly request everybody to
Can you?
do the things. I can't see your screen yet. Go ahead.
There may be some settings. I can share it in chat.
No, walk us through.
Actually, I don't know why it is.
You share the chat. Share in the chat. I'll put it on my notebook and then you can do. All right.
Yeah.
I'm going to open another notebook today. Date today is June 2020 and PG certificate. All right. All right. Anyway, I think Abhijit, in that case, what I would suggest is share your code in the group along with the animations that you followed so that everybody else gets a bit of inspiration and can do that. Okay. The main idea is that get everybody to do the code. Okay.
I will share it in WhatsApp.
Yeah. Please share in the WhatsApp along with the animation URL, the one that you follow. Okay. Perfect. And there we are. Let me open the. Okay. I actually want to just, get to there are a couple of data structures that I want to finish. And then we finished the file reading last week, right? And so that I get everybody to do the to okay. All right. Okay. Okay, never mind. Okay. Yes, I found it. And okay. All right. I want to start with something super simple, and then the thing that I've been waiting for some time. Okay, so everybody is okay with the tuples so far. Tuples are like dictionaries. I can just finish it in 2 minutes and then we can move on. There's nothing much to worry about on tuples. Okay, so usually what happens is that when we are defining, say, two variables and coordinates and so on, it's easier to do tuples than doing the list. Okay, say for example, tuples are very much like lists. So if you have Glenn, Sally, Joseph, and you put them in a tuple, so you notice that instead of putting a square bracket, we are basically just putting the round brackets. This is like list. But inside it, what it is doing is it is creating an object with these values. Okay. And this makes it extremely fast as opposed to the array. The downside of, right, I'll just give you, okay, how do you, yeah. How come it's not connected with mine? Okay, just give me a moment. I don't know why my pencil is not connecting to this. Okay, how do you connect? Only draw with the pencil, scribble, bottom left. Okay.
Sandeep, I can see on the white screen.
Yeah, I have put the white screen.
Yeah, now I can see.
Yeah, my pencil is stopped connecting. Just give me a moment. I'll check with my kid. I think the pencil got swapped with him. Okay, so let's see if I can do it with a pencil. Okay, this got disconnected. Seems like it got connected. Good. All right. Yeah. So basically the tuple looks like same. Okay. So essentially, okay. So basically tuple and list. Okay. So the way you define a tuple is like this: 1, 2, 3. So these are the values, and list you define like this. Okay. Both are same. Now, efficiency wise, right? This is very efficient as compared to the list, less efficient. Okay. This is good for few values. Okay. Just few values. When you have, let's say, 100, less than 100 values, tuple is a great idea. Okay. This is the biggest difference that you will notice is that this is read only. This is, this is not a read only. You can do read and write. Okay. So you can define a tuple, but you cannot change elements of it. Okay. This is great. So what it does is it basically, say, for example, you have to define a rectangle. How do you define a rectangle? How many numbers do you need to define rectangle?
4, right?
4. Correct. Okay. So see, you have to define a point. Okay. So point is x comma y. And you don't want anybody to change these values. Okay. So you would want to define a point using a tuple. Because let's say you're passing a point to a function. Let's say, for example, I'll just give you a very good example. Let's say here, okay, let's take it. Okay, and there we go. Let's say we are trying to find the distance between 2 points. Okay, distance between 2 points. Okay, point 1, point 2. Okay, now one way is that we can pass the 4 coordinates here, or we can basically call it like this: P1 equals 1, 2, P2 equals 2, 3, and then we can say distance point P1, P2, like this, right? And who can help me writing the logic? Okay. All right. Who will help me writing the logic? Saradeep, Sweta, Deepak. We are trying to find the Euclidean distance, yeah, between 2 points. Yeah.
Sorry, I know the formula, Sandeep, but just trying to kind of convert it into this Python syntax.
Yeah, just tell me. What's the formula?
I think P2 square minus, like, square root of P2 square minus P1 square.
Okay. So we are basically trying to find this distance, right? How much is this distance? How much is this distance? So this one is x1, y1. This one is x2, y2. So this, right? How much is this distance? Quickly.
x2 minus x1.
x2 minus x1. x2 minus x1. How much is this distance?
y2 minus y1.
y2 minus y1. Now, how much is this then? So the base is P1 dot P1 0 minus P2 0. Okay. And perpendicular is P1 1 minus P2 1. That's okay. P1 and P2. All right. So, okay. Now, how much is hypotenuse of this triangle? Or let me just call
This
it
Square root.
Yeah. Square root, right? Math. Okay, let's say hypotenuse equals to math dot sqrt. And then base square
plus
plus.
perpendicular square.
Okay, that's it. Okay. Yeah. So you are able to find the distance. It turns out to be this. You will be able to do it with pen and paper, right, everyone? So this is 1, this is 1, and therefore this is square root of 2. Yeah. Right? Now, we could also do it by passing the list. If we just change each point to a list, then also our code works, right? Then also our code works because the syntax of accessing a particular element is same in both. All right. So here we were able to quickly swap. Now, why would you like to pass the point as a tuple, not as a list? Which one would you prefer, everyone? Would you prefer the point to be passed as a tuple or a list?
Tuples.
And your reasoning is?
Because they are not going to keep it fixed. There will be only two parameters.
Okay. Okay. The other thing is, other reason is I do not want this function. I'm handing over this function of my point, correct? I'm handing it over. I don't want this guy to modify my tuple, correct? I don't want this guy to modify my tuple, right? In Java or in other programming language, what you will define is you will define a data structure called point, and then you'll make it read only. Okay, you'll make it read only. And you don't want to basically let this function change your data. So when you're passing it like a tuple, you are assured that this guy won't change your point. Got it? So that's why tuple is quite useful. Okay. And yeah. So when you have, I mean, the thumb rule is when you have this need to create your own read-only class or object, and you want to pass it around, instead consider tuple. The way tuples are implemented in Scala and other programming languages is that tuples underneath create anonymous classes and objects underneath and put the values there. Okay, that's a very common thing in Scala. That when you're creating tuple, it underneath creates a class with those many variables, and you can access them like this. You can access them like p1 dot underscore 1, p2 dot underscore 2, like that. Okay, so yeah, I hope you got the picture. So that's called a tuple, and there is nothing more than that to the tuple. Okay. Okay. Now, yeah, you can basically just, you will find it very often that many a thing are tuples, okay, in Python. Similarly, assignment is there. So you can assign two values to a tuple, okay? If you have, let's say, this is one tuple, x comma y, and you are doing this is essentially creating assigning x equals 4 and Fred, y equals Fred. Also keep in mind that when we are saying things like this, okay, when we are saying things like this is a value. Automatically, tuple with a single value get converted into normal thing. You can see type of X is an integer. It's not a tuple. But if you say 1, 2, then the type of this is a tuple, right? All right. Yes, go ahead.
One comma also define the tuple, I think.
Yes. So
We
now
not define.
if you have a tuple and you need to create, you have a tuple with one single value, what would you do? You'll put a comma here. Okay. Is everybody okay with this?
Why would someone want to, assign a tuple, right, with just
Good question. Good question. Honestly, that's a big thing, big important thing. Imagine that somebody is dealing with let's say this is a distance. Okay. And let's say there is a case where we don't want to pass the second variable and let distance method deal with it. So instead of changing the distance point to take the input as a single value, you would like to pass a tuple with a single value. Okay. Essentially, those are the corner cases. There are few rare cases where you would like to give the tuple with a single value. And that's why by default, a single value tuple automatically becomes a normal value. Okay.
okay, thank you. Yeah.
Perfect. And all right, you can also, yeah. So then there is dictionaries, the comparison with dictionaries we have already known. So when you are asking things like dictionaries to give items, it automatically gives you a list of tuples. For example, let's take a look. This is my dictionary, and I am putting elements into it. I'm saying, right, okay, name equals Sandeep T, okay, height equals 155. I don't know how much the height. And so this is my tuple. Okay. Now, if I say t dot items, okay.
This is a tuple or dictionary? This is dictionary, right?
Sorry, this is a dictionary. This is a dictionary. Okay. This is a dictionary. Again, extremely sorry about that. This is a dictionary. And when I say items, what it gives is, it is giving me a list of tuples. Of course, it's a custom list called dict underscore items, but it's essentially a list. So you have list of tuples. Okay. And each tuple contains key and value. Key and value. Each pair is containing key and the value. All right, everyone? Okay. Tuples are comparable. You can compare tuples. Okay. Also, dictionary's key can be a tuple. Okay. Let's say you have a coordinate system and you are saying put one comma let's say a at 1, 2. So this is a valid key. A tuple is a valid key, while I don't think the array is a valid key. Okay. Array is not a valid key. Okay. Unhashable type, because array or list is not a hashable type. So tuple is a valid key, but list is not. Okay. List is the only kind of thing that can't be handled with dictionary. All right. Is everybody okay with this? Now moving on.
Yes.
Perfect. Perfect. So, all right. So you can deal with it. You can essentially, if you create a list containing tuples, you can just sort it. Okay. All right. That's pretty much. Now, I want to move quickly to another topic. Okay. Another topic is object-oriented programming. I'll come back to the regular expression later. Okay. I want everybody to start creating their classes and objects. Okay. And I want you guys to start working on the classes and object. I think I'll follow their main tutorial. Okay. Classes and objects in Python. Okay. So where is, yeah. So in case of Python, you can create your own classes, your own data type. Okay. And essentially, you can define your own methods. All right, let's take a look. So to define your own class, you can say class and my class. Okay. And here you can define something called not, you can define methods in it. Okay. The most important part to know about the class, that the methods defined inside the class should take one argument called self. Okay. Self points to the object when it is when you want to use it. Okay. Let's say we have here, this is the constructor. This is the constructor. And okay. All right. So where is my, yeah. So this is my constructor. I can give it some variable arguments. Okay. And then I can set the names like this, the values like this. Okay. And then when somebody says print name, okay, I can say print and self.name. Again, here self is mandatory. So here I just defined a class called my class. Okay. Class called my class. Okay. Now I can create its object, my object equals my class. And I can put the argument here. Okay. And the argument is, let's say my name is Tommy. Okay. Or let's say I'm defining a class called, let's say dog. Okay. I'm defining a class called dog. Okay. And I'm giving it a name called Tommy. And all right. So I just created my own data type. So class is like a data type. Like the way we have dictionary, we have list, we have tuple. Similar to that, we have dog now. Okay. Dog takes an argument called name while you want to create an object. So we created this object of type dog. So dog is like a data type now. So we created a variable called my object of the data type called dog. Okay, just like you have integer, just like you have a string, just like you have thing, we have now a dog. Dog with the name Tom. And when we called this constructor, notice the constructor here. Constructor is defined just like another function. The only difference is the name. Double underscore in the beginning and double underscore at the end. Okay, that's all. Okay, now when I'm saying print name, okay, I'm not passing any argument, only self. Okay, self is just extra argument. You can also call it S, or you can also call it anything that you want. Okay, so I just defined this function, and then I'm saying print underscore name. Okay. So notice it very carefully that here we are passing this self object, right? And essentially, when we are calling this, we are saying my object dot the function name without the self object, isn't it?
Right. So, Sandeep, just to compare with Java, like in Java, we used to have this keyword, right? Where
Yes,
without,
yes,
so that is not kind of possible here. You have to pass the
yes.
object.
You have to pass that.
Okay, the reference. Okay.
Yes. Okay. Is
Sandeep,
this
it's not clear actually. Sorry.
okay? So
Can you explain again, please?
yeah. So what are we trying to do? We are creating our own data type. You are not happy with int, you are not happy with the string, you are not happy with list. You want to create your own data type called dog. Okay. So once you created the data type, right, you want to create an object of this type. Okay. Like if you have instead of a dog, let me give it a better example called customer. So customer could be, okay, customer, we just defined our own type called customer. Now customer could have name and customer could have the address, and customer could be, okay, premium. Okay, so we are defining these parameters. Okay. Okay. So we are defining a class called customer with all these parameters. Okay. So that when we say customer will be, okay, like this. Okay. So here it says that it is, okay, what is happening here? It says name select is not defined. Name. Oh, all right. Now, are you clear? So we are defining a customer with a constructor in it, and we are saying that whatever, right? These arguments you see, John goes into name, address, and premium. Okay.
Sandeep, why we are using this self.name, self.address?
Yeah. So when we are essentially, when somebody says self dot something, correct? What's happening is, or let's think about this print name method. Okay. This print name method. Okay. What does it do? Okay. So I can call the variable on top of the object. Okay. Internally, when calling this print name, it is calling print underscore name with my object. Okay. This, and this. Okay. Like this. All right. So internally, what it is doing is whatever object is there on which we are calling the print name, it is passing that object here so that you don't touch any other variable, because the class is a blueprint. Class has no clue about object values, right? So that's why you have to pass in the name of the object, the variable of the object as the first argument on classes functions. Okay. So like, for example, if you have two customer, this is, okay, this is my object one, and let's say this is Vineet, and this is, say, 2, 3, 4, and this is not premium, so I'll just say false. Okay, so when you access my object dot premium, that is true, and my object 1 dot premium is false. So these are two separate objects. They don't have an overlapping value. Why? Because we are keeping the data inside the self object. Okay, the customer is a blueprint. Got it? No? So when we are defining a class, what are we trying to do? We are creating a blueprint. And when people are creating an object like this, what it is doing is it is allocating this particular line. What it is doing, it is in the memory, it is putting John, then 1, 2, 3 street, and then true. Okay, and then it is making my obj point to this. Similarly, here it is Vineet 2, 3, 4 street and false. Okay, this is my obj1. Okay, so basically when you are dealing with the complex systems, you will have to create your own data types. Okay, and a data type can have its other variables to store inside it. A data type can have its own methods that can operate on that particular data type, such as here we have print name. So a class has the constructor. Class has, this is called a constructor. Here the init method is a constructor. When we are calling the customer like this, internally it is calling the init method. So when you're creating an object of customer type, this is how you create the object of customer type, and then internally it's calling the init method. Okay, so this is a strategy to create complex data types of your own, right? Is everybody okay?
Sandeep sir, I have a very basic question. I'm
Yes.
still catching up on basics, practicing less than I should, but I will. Why do we need to create our own data types when
Yes.
there are so many
might-
exist
yeah.
already?
You might happily say that, okay, I can just put this as a tuple, right? You could say my object as tuple. And there's nothing wrong in it. Okay. 90% of the life will basically be solved with tuples and existing. So you would hardly ever need to create your own classes. And you will again and again question this part that, hey, why should I waste my time creating classes? I can just, finish everything with my tuples and other things. So yes, answer is that you don't need to create many number of times, but there are some scenarios where you would like to do. Like, for example, there are, let's say, lots of functions. Like, for example, we have a list, we have, let's say, list class. List class has append method, list class has remove method, index method. So there are so many methods and there are data types. So you would like to put all of them into one bucket, one package, and just use that. Just like a string class. A string class is essentially having so many methods. When we say s is equal to this, it is internally creating a string object. If you see the type of this object, it has created the string object. Now, when this string object has these other methods like capitalize, so on. So you may want to create your clean method in which you have all kinds of things. So let's take a very, very good example. Okay, let's take a good example. And I want to start with this, right? I want to start a real thing. Okay. Okay, there are a couple of questions that let me just answer. Tuple, okay. Question from Nikita is the init function similar to main? No, init function here is similar to that constructor. That how do you define constructor again in Java, you define it with the same name as the class name, right?
Right, just the same name as the class.
Yeah. Same name as class. So it's a constructor, the init method. Okay.
So
In case of Python, you don't have a main method. Okay, you can just write the code as is, and that's a main method. Okay. All right.
So,
Okay.
But then in Python, Sandeep, how does the execution starts? Like in Java, it starts with you invoke the main function, right?
Everything is main in
Everything is main. So you whatever method that you want to invoke.
Yeah. I'll just show you. I think where is my classwork? Is this? Yeah, this is the classwork, right? So I can just create a new text file. Okay. And the name of the class I'm keeping as hello.py. Okay. I'm just saying print 1 + 2. Okay. This is my main method. All right. Let's see if I go here. Where is my terminal? I can say Python. And all right. So what was the name? I had said hello. And there you go. So it just ran. Okay. Similarly, if let's say we are doing this, okay, we are doing this, we can just copy paste this code here. Okay, we just copy pasted the code, and in the end, we can start using it. Okay, we can start using it like this. All right. Where is the class? Here. And then there we go. All right, there we go. We can just say, all right. So we basically copied everything except for we had to add extra print because Jupyter Notebook was automatically printing the value. Okay. Here, when you are doing this, you have to put the class name. Now going to the terminal, and then I'm saying hello.py. Yes, worked. Okay, just that there is none printed. Let's take a look. Where is this none being printed from? Okay, so I'm saying, oh, here, this was not really required because print is happening inside. It's not returning anything. That's why it is printing none. Okay, so there we go. Perfect. Is this making sense to you?
Yes.
when I run the type function on this new data type, so what will be the value? I mean, what will be the data type
Okay,
for this?
let's see. So type of my object, what should it be? Can you guess? Tell me.
Class name.
Which is customer. You can see customer. So yeah, it's underscore main dot customer. This is the name of the page and the customer. Okay. All right. So we have successfully created the class and we are using it. Okay. Yes. Let me further try to convince that this is useful and it is needed. So now let's try to do something cool. Okay.
So, Sandeep, I have a question. I mean, is there any default constructor in Python, like in C++ and Java? We have default constructor.
I don't
Like,
think so.
okay.
I mean, if you just skip it, it'll work,
Mhm.
right? It will work, but you want basically have extra variables. You can basically, I mean, there is a default constructor. Even if you don't have the constructor, this
Yeah.
would work fine. Okay. Like
Okay,
for
and then this
example,
will involve. Okay.
yeah,
Okay.
you can say X, and then you can say, right? You can say, all right. Yeah. Okay. So notice that this is a class level variable. All the objects of this class, okay, will have the same value. Okay. So, all right. So if I say y dot small x, that's also 10. Y1 dot small x, that's also 10. Y1 dot x equal 10, not like 100. So this will become 100. This will become 100.
Okay.
Sorry. This, no, I was wrong. No, this remains as 10. This remains as 10. By default value, okay, so it's essentially copying that initial value and then, no, this is not a class level. This is created a proper variable. My understanding was wrong. Okay. And you can see that, right? So the class level variable still has the 10 value. So it basically creates a member level variable, and then you can modify that.
Okay, and by default, the scope or the visibility will be public, right? I mean, but we have
Correct.
options to create the private and
There's no option. There's no
okay,
option.
there's no option. Okay.
Yeah.
So that polymorphism or abstractions never comes into picture in the case of Python, right?
Abstraction is there. Abstraction is there, but the privacy protected public and all is not there. Okay. And it is by design because it doesn't make much sense in case of Python. As per the design, they have not put all those constructs. Okay.
Okay. But do we have that drive classes kind of concepts like we can drive?
Yes. You can inherit. You can inherit the classes. Okay. So you can basically, you have the polymorphism, you have everything, but I don't think it has the private and protected and public methods. Okay. Now, before we move forward, I want to I can go into more details about these classes, and I would go into more details, but I want everybody to solve this simple problem for me. Okay. So, all right. For a problem, our input data, okay, so very simple ML problem, okay, and it's something that you have all done in 7th, 8th grade, okay. Okay, so problem statement is this: when okay, so when input data, let's say x was 1, y was 5. When x was 4, y was, let's say, 8. Okay, what will be the value of x, y at x equal to 90? And what will be the value of y at x equal to 2.3? Yes? How would you do it? This is a straight linear relationship. So for when input was, okay, the way, let me just draw it for you. Okay. When input was x equal to 1, y was, let's say, 5. When x equal to 4, this is 2, 3, 4. When x equal to 4, the y was, let's say, 8. Okay. Now, there's a line joining them. Okay. How would you find this line?
We can find the equation.
Okay. Help me find the equation.
So the equation is x minus x1 upon x2 minus x1.
Okay. Do you know where this formula came from?
I think while studying coordinate or the linear equation, I studied this formula.
Yeah. Okay. What's the equation? What's the linear equation?
So the order is 1, that's it represents the straight line.
Okay,
So
yeah. Tell me the equation of the straight line.
x minus x1 upon x2 minus x1 equal to y minus y1 upon y2 minus y1.
X minus x1 divided by
x2 minus x1
x2 minus x1
should be
equal
equal to y minus y1 upon y2 minus y1. I think I might have
no, this is okay.
okay,
So it is
okay.
essentially what you are saying is that if you draw a triangle like this, right? Okay, then basically you are saying that the slope is similar, right? The other way to look at it is, okay, the other way to basically look at it is this. You can just say that, okay, okay. The other way to look at it is this. Okay, you can say y is equal to mx plus c. Okay, meaning y is if you multiply x with some number and add something to it, then you will get y. Correct? So m is called slope and c is called intercept. Got it? Now, let's take a look at if we can find m and c. Okay? Yeah, tell me. Who can help me find m and c? So these are the two data points. Everybody, is this okay, everyone? Yes, I would be swinging between maths and coding and machine learning, but right? But it's by design. It's not, it's a feature, not a bug in my classes. Okay. So
Putting the
and
value of, we will get two equations from the 2
yes.
points you get.
Okay. Yes. Yes. Help me with those equations.
So 5 equal to m plus c.
Okay. So basically we are saying we have this is the equation of the line. We know that y is 5 at x equal to 1. All right. So this is my first equation. And second equation is what?
8 equal to 4m plus c.
Perfect. Now, can you solve these two equations?
It's m equal to -1 thing. So subtracting both the equations.
Yes. Yes.
M equal to 1, sorry.
Right. So this will be 8 minus 5 is 3. 4 minus this is 3. So m equals to 1. And c is equal to
4.
4.
Yeah. All right. All right. Now the question to all of you is, okay, this is all good. This is all good. And let me go back to your previous technique. This is all clear, right?
Yes.
Yes. Yes. Perfect. Perfect. Now, all right, let me just clear it up. Okay. So if I ask you guys in interview this question, you'll be able to solve it, right? Okay. So now once we know that the equation of m was how much? M was 1, right? So the equation turns out to be what? Y is equal to x plus 4.
4.
You can test it out, right? So x was 1, so y became 5. 1 plus 4 is 5. X was 4, so 4 plus 4 is 8. So our equation is correct as per these two data points. Right?
How m is 1?
We just solved the equations, no? Two equations. You missed that part. Should I repeat that?
Yeah, I mean, in that only I cannot understand how m is 1.
Yeah. Like, see, if I put this 5 equal to m plus c, and 8 equals to 4m plus c. Solving these two equations, you'll get m equal to 1 and c equal to 4.
Okay, got it.
Right? You can subtract these and 2 and you'll get 3m equal to 3 and m is 1. Okay, then you put m back into this equation, you'll get c. Is everyone okay with this? Not okay?
No, okay. But we have to solve this programmatically, right?
Yes. Yes. Okay.
Define a function for this.
Yes. Yes. Let's do it programmatically then. Okay, let's do it symbolically. Rather than putting these values, now I'm going to just change this thing a little bit different. Okay. So let's see if we can solve these two equations. Same way, what we did for here by putting these values. So we'll say y1 equals to m of x1 plus c, y2 equals m of x2 plus c, right? We subtract these two equations. That gives us y1 minus y2 equals m of x1 minus x2. And m turns out to be y1 minus y2 divided by x1 minus x2. Is that okay?
Yes.
All right. Now, if I do this, that I multiply the first equation with x2 and second equation with x1, right? And then subtract, what will happen? This will get eliminated, right? So I will, right? I'll get something like x2 y1 minus y2 x1 divided by x2 minus x1. That's C. Okay.
Yes, Sandeep.
Okay. Now, okay. All right. Unable to save. Don't tell me this. Zoom photos. Okay. Do I need to give the... Oh man, my work is gone. Okay. Let me just take the screenshot of this, okay, as a reference. Yeah, I'll just keep this as a reference, okay? And this looks super messy, but that's okay. And I will say annotate and clear. So I've taken the screenshot of my drawings and I'm going back to where I was. All right, moving on. Okay, so yes, so we found the formula. Did anybody make a note of it? All right. All right. So we said m was equal to how much? Okay. We can define a method called slope and find it. Okay. Now, let's define a class to do this job. Okay. The class will have those simple functions that will help me. Okay, I'm again connecting my iPad. So the class will have those simple functions that will help me, make it super simple. Okay, so here I'm trying to create a class called algorithm. Okay, we'll call it what algorithm do you want to call it? So this is like the simplest machine learning problem, whereby you have historical data, you have the value of X and Y, and then once we have built the model by drawing the line, that line is my basic model. Okay, now once we draw the line, we have figured out what's the slope and the intercept of the line, then we can predict the future. We can give X to it and it can tell me what will be the value of Y. In our case, the model turns out to be, what was the model? Y was equal to M plus C, correct? M plus 4, sorry. My model was Y equals to, M was 1, so X plus 4, right? That was my model. Now I can put X equal to 19, so Y will be how much? 23. And X equal to 2.3, so Y will be 4.6.
6.3.
Right? So once we build the model, I can just do it quickly. And notice that to find the model, it took a bit of calculation. Do you notice that? To find the model takes a lot of effort, but to use a model is spontaneous. Right? When we hear that large language model got trained, took so much time, it's similar to that. So figuring out a model takes time. Figuring out that model that goes through these data points take time, but prediction takes way less time, right? Mostly, yes. Okay, now going ahead. So I'm defining the algorithm called, right? We call it a straight line. Okay, straight line, we'll call it 2 points. Okay, that's the algorithm right now. It's pretty simple, or you can say linear regression with 2 points. Okay, and we can give it the name that we want. Okay, and it has no as such nothing. Okay, right now we are going to define only 2 variables. One is slope and other is the constant. Okay, and then we have a method called fit. Okay, what does fit do is, fit basically, okay, takes the data and learns from it to create a model, right? So we are giving it, how do you want to give it? We are going to give it like the data in the form of an array of points. Okay, we will give it array of points. Okay, points will be tuples. Okay, so this will be our, we'll call it points. Okay, of course it'll be the array of length 2. Okay, we will extend the same thing for future. Okay, we'll extend the same thing for future. Are you guys okay with me? Or let's just put it this way. We will pass X and Y like this. Okay, so we'll pass X coordinates and Y coordinates as this. So we will fit our data. Okay, for now I'm not coding this. And then we will have a method called predict. It takes X and returns Y. Cool? So you are just coding your first algorithm. Okay? All right, let's define our self.m. Does anybody remember the formula? How much was the formula? For how much was M? How did we calculate?
y1 minus y2 divided by x1 minus
y1. So y is an array, x is an array. So we are saying y1 minus y2, right? Divided by x. Correct? Is this okay? And x and c?
By 2x1, that means y0
Y x2 y1, x2 y1, right?
x2 y1 minus y2 x1
x1
by
and
x2 minus x1.
this is easier, no? If I do this way. Okay. All right. So I can say y2 minus y1 divided by x2 minus x1. And here it was x2 y1 minus y2 x1 divided by x2 minus x1. That's what we derived, right?
Yes.
This one. Okay, x2 y1, y2 x1. Okay, perfect. So, and then prediction time, who can help me? So, prediction time, we'll be given one value of x and we have to, or we'll be given an array of values of x and we have to return an array containing values of y. So, we can say capital X, okay? And for each x, what we return? Return self.m multiplied with x plus self.c. Okay. I always forget to put the self everywhere. So I'm going to put self everywhere. Okay. And yes. Did I miss somewhere? Okay. And
So,
I
Sandeep,
made a mistake. Yeah.
Sandeep, so we have to like put self everywhere wherever we are defining like a constructor
Or a method.
Okay.
Okay. The first argument has to be the reference to the class object, the object. Okay. Did I make mistake? Did I make mistake?
But self is not a keyword, right? So you can, I thought you said you can use s as well, whatever variable name you want.
Yeah, whatever you want to do. It has to be the first argument. Okay. You can use this. Okay. All right. Define this. Oh, I forgot the colon. Okay. Do you think this will work? Let's see. Okay. I'll call it model is my object, and I am defining I am basically defining this. Okay. Now I am saying model dot fit. Okay. And I am passing 1, 4, x values and y values are 5, 8. And okay, the model got trained. And I can, right, we can use it for prediction. I have to predict for x equal to 19 and 2.3. And there we go. Is it working?
Yep, great.
Right? Is everyone okay with this from statement?
Yes.
Yes, sir.
Right?
You don't know it, Samir, but you have just demystified all the AI machine learning jargon that I've been hearing for the last couple of years.
Yes, yes. So that's a power of code. You know, when you see the code, you see the things. This is something very important. Now, it's a very important thing to know that almost everything that you see is around prediction and learning. Okay. When I see maths, if you think about maths, we have the past experience of the world and we are trying to predict the future, right? So the entire of maths, physics, chemistry, biology, or every branch of computer science or human sciences that you have gone through, everything is essentially predict for survival. Okay, whether we were predicting the year, minutes, time, whatever we have done so far in astronomy, astrology, wars, everything is essentially prediction for survival. You'll see that this pattern repeating very often. Like, for example, what's a dictionary? You keep on putting the past values into a dictionary, and then based on the past values, you start recalling them when you need them, right? That's a kind of an overfitted model where you put the data, it kind of memorizes it, and then it can only answer the things that you have kept in this. Okay, so most of the things that human has devised is basically around prediction. Okay, so almost everything. Okay, so almost everything around prediction, and the maths as a machinery is its entire crux is around find X. Okay, prediction in certain dimension. Now coming back to it, and this is where you'll find it very interesting that almost everything can be simplified so much that everybody can understand it. Okay, because this is something that we are pretty good at. We are really good at learning things. As when we're born, we started learning everything by ourselves, and we were so good at it. And so we understand prediction. Almost all of us understand prediction. Okay, it's just that the jargons that confuse everyone. All right, good. Very happy to see that this is useful to all of you. Yeah. Okay. So, all right. So we just coded our first model, very basic model. All of the algorithms that you would study as part of the machine learning will have the same pattern. You will have a class, which will have a constructor. Constructor might have some more arguments for the algorithm. We call them hyperparameters. The class will have a method called fit, where we pass the input data and the expected outcomes. Okay, this is the input data, expected values. We call them, Y is called labels, X is called the instances or experience. And then here, there are two variables representing our mental model, which is a straight line is being represented by two values, slope and the intercept. And the prediction is essentially given X, predict Y. All right. So everybody okay with this? All right.
Yep.
So question to all. Right. Question 1. Okay. Repeat the above process for 3D. Okay. Which means now you have X1, X2, and you have to predict Y. Okay, so you have X and X1 and X2, and you have to predict Y. Okay, which means you have 3D data point, let's say 1, 2, 4. Okay, and you have, let's say 2, 3, 8, right? And you have third data point called, let's say 5, 7, 19. Now, given X1, X2, let's say 4, 5, you have to predict Y. Okay, so can you build a model around it? So you have to define a class. Let's say we call it plain class called plain 3D. Okay. And you have to basically follow the same process. Okay. Same process. It's going to be fairly hard because the formula that will come out is going to be really complex. And this is not generalizable. This is not generalizable because this is basically only for 2 variables, not for 3. Because here you will get an equation in 3 variables. So you will define your y like this. Y equals to m1 x1 plus m2 x2 plus mc. Let's call it c. Okay, so you will have to find m1, m2, and c given the data point. Okay, so now you notice instead of 2 variables in your model, you will have 3 variables called m1, m2, and c. Once you have found out these 3 variables, you can predict the value of y given x1, x2. Okay. Are you guys with me so far?
Yes.
Will you be able to do it?
Means I guess we need to first find the formula, right?
Okay. All right. I'll park it aside. I'll give you time to think. Okay. Now, question is, now the next level question is, okay, how would you do it for n dimensions? You have x1, x2, x3, x4, x5, x5 like that, and you have data points. Now you have to do it for n dimensions. Okay. So it is very clear that we will have to come up with a code that can solve equations, correct? Instead of we solving the equations, we let the code solve the equations. Rather than we coming up with the formula, let it solve the equations. Okay, so now, right, I hope everybody's okay with me so far. You're not zoned out, right?
No.
I'll take a pause.
Hello, sorry, I probably missed something. So first one, there is prediction, right? Which formula you have already written. So that is like you are writing the same thing, right?
Yes.
So it is also not prediction by
Yes.
machine, right?
So see, yeah. So the thing is, even in case of large language model, everything will be coded by people. But it's a prediction by machine because it is learning from the data. This is the data given to us. Our model learned from the data and then started predicting the future. Do you see that difference? So when we say machine learning means learning from the data and then starting to tell the future or past or somewhere in midway. Okay.
So this is same as calculator programming or something or whatever basic programming, right? Because we have already written the formula.
Yes. So the human has to come up with the formula. And sometimes coming up with the formula is hard. So you will have to use computer to create that formula. Okay. Now that's my next question. If let's say you have n, here I talked about three variable situation, right? So we said, okay, this time we will have y equals to m1 x1 plus m2 x2 plus c. Okay, and we'll put this value. We'll say 4 equals to m1 plus twice of m2 plus C. Then we'll say 8 equals twice of M1 plus thrice of M2 plus C. And we'll say 19 equals 5 of M1 plus 7 of M2 plus C. Right? So we got 3 equations. And how many variables you have? 3, M1, M2, C. Can you solve this equation? Is it solvable? Can you find M1, M2, and C using these 3 equations? You can, right?
Right.
Yes.
Perfect. So coming up with a formula is very hard in 3 variables. That's why I threw this problem so that you can think over it. And the question is, can you design a tool that can solve the equation by itself? Okay. Now let's try to do that. Okay. Okay. So here is a question, right? Write code to solve equations. Okay. How would you like to represent the equations? Anybody wants to step up and help me? How would your function look like? Let's define a function called solve equations. Okay. You are taking equations. Let's just call them X and Y. Y is on the right hand side, and X is the matrix representing all the coefficients. Okay. Or let's just put it in a single list of lists. Okay. We'll put everything on inside a list. Okay, list of lists. Okay. Can you solve this equation? No. So can you right, when I call this, let's say I put everything like a list of lists. Okay. My equations, I can just put it in a list of lists. I can say equations equals. Okay. And I can say what was my coefficients? Can somebody help? 1, 2, 4, right? And then I have 2, 3, 8. And I have 5, 7, 19. Okay. So I want to use this to solve equations. Given these 3 equations, okay? Given these 3 equations, right? So given these 3 equations are represented like this. 1, 2, 4, 2, no. There is one thing missing here. It should be 1, 1, and 1. Okay, now it makes sense, correct? So 1, 2, 1. I put all the coefficients of these things into this. Okay, 2, 3, 1. 5, 7, 1, and last value I've just put from the right hand side. Okay, so when somebody gives me this, okay, so we want to solve equations. Who can help me? Do you think so? This is how I want to represent my equations, and I want to call your method called solve equations with this. Okay, is it too much maths?
No, means we can do it, but I think it will take some time, some thinking.
Okay, okay. Take your time. Can you convert it into recursion? How do you usually solve an equation?
I think fine. First solving two equation and putting into the first equation.
Correct. Correct. So one of the techniques that we have done always in this is that we will convert this into two variables. Correct? Right?
Yes.
First, if let's say we have three variable equations, so we will convert three variables into two variables and two variables into a single variable, and then we'll solve it. Okay? All right. All right. So let's try this out. Okay. So if all right, if somebody calls solve underscore equations with, let's say, 1, 2, we can tell the answer. 1, 2 is basically same as saying x equal to 2. So like the way we have represented here, m1 x1 m2 x2 plus c is equal to 4, correct? This is 2 m1 3 m2 plus c equals to 8. This is 5 m1 plus 7 m2 plus 1 c equals to 19, right? Similarly, this equation is basically nothing but x equal to 2, correct? If it was, let's say, 2 like this, okay, and here. So what I'm trying to say is that in case we find that there is only single equation left, we can simply return the value of x, isn't it? Are you okay? Like if somebody says to you x is equal to 2, then you can solve it, right? Okay, let me put down a simple process. I know that all of you have been out of touch with the maths for quite some time. Okay, let's just try to solve a simple thing. Okay. Okay, I've just put down these values randomly. Okay, so first of all, what we'll do is using the first equation, we will eliminate z. So we'll convert it into two variable equation. So when you add these two ones, z will be eliminated. So you'll get 2x plus 2y equal to 21, right? When these two are added, what do you get? 3x equal to 3x plus 0y, 3x plus 0y equal to 28, correct?
Isn't it minus 2z? Like 3x minus 2z equals to 28?
No, I just added the first and last.
Oh, first and last.
Yeah, these two. So I am using the first equation to basically eliminate z. Okay, so I combine these two, so z got eliminated. Then I combine these two, z got eliminated, right? So from 3 variable to 2 variables, correct? Okay. And now I would basically, what would I do? Okay. This is, I'll just make it a simpler case and then we'll...
I mean, maybe I am wrong. That first and third equation, I think x will be left, right? Because it's okay, now it's 2y, then it's okay. Because earlier it's a plus y minus y, which will be nullified, right?
Yeah. So I will just make it minus y. Yeah, this is better. No?
Yeah.
Okay. Now, what I would do, I would basically, using the first equation, I'll eliminate y now. Okay. So how would I eliminate? Divide the first equation by 2 and add with the second one. So this will become 4x equals to 28 plus 21 by 2. Correct? Right? And then,
Sandeep, can you repeat this one? Sorry, I missed.
what I did was I divided the first equation by 2 and added with the second one.
Okay.
So 2y became y and then got cancelled. Then 3x plus x, 4x, and this side became 28 plus 21 by 2. Okay. So first we eliminated z, then we eliminated y, we are left with x. Correct? Okay. So x will be equal to 28 plus 21 by 2 divided by 4. This much. Okay. We calculated that and then return to this guy. Now, I told it that x is equal to this, and using one of the equations, it will calculate y. And once that is done, it would basically give the x and y. And then this guy will give x, y, and z. Okay. So if we define a solve equations method, which is calling itself recursively, so what solve equations should do is take the first equation, eliminate the last variable, take the first equation, eliminate using the first equation by subtracting or adding with the rest of the equations, eliminate the last variable, you will get you will keep on dropping one variable. And in the end, when you reach to a situation where only one equation is left, then solve it and give out the value called x. That's it. And then you basically use it to return the other variables. No? Yes?
Yes, Sandeep, that's right, correct. We're with you.
Oh. Can you help me code it? Okay. It's a real interview question. It has been asked multiple times. And this is usually an hour of interview. Okay. And if you can solve this in that 1 hour of interview, it is guaranteed that you will get selected. Okay. Because this question being asked is, it only signifies that this is probably going to be your last, the bar raiser, we call it at Amazon, bar raiser, or it'll be basically something like a qualifying round. Okay. And yes, I mean, my expectation from a data scientist, a senior data scientist, is that he should know coding, he should know maths, and he should know machine learning. It should not be either. Okay. If somebody doesn't know maths or coding, it'll be very difficult for them to cope up with the machine learning. Okay. They might pretend, they might memorize, but the moment the problem arises, they can't handle it. Okay, that's why even though it's a Python course, I want to reintroduce the maths the way it's used in machine learning. Okay, you will see the magic. Like you never thought that how equation solving is going to help in prediction, right? Here, this is where the equation solving is going to help. Okay, and it's not only in this. It's not only in a straight line or plane or something. Approximations as well as quadratic equation. We call them bicubic estimation when the data is like a polynomial. And it's specifically used when you are estimating the traffic really fast. The traffic is coming from the end user side really fast, at that point of time, then you use this bicubic estimation, specifically auto scaling, detection of prediction of the load in couple of minutes. So everywhere that bicubic estimation, where you are saying that my data is y equal to 4ax, okay, and plus c, okay, something like that, right? So you will see that very often. Okay, we'll talk about that very soon. But knowing how to solve equations is the primary thing in computing. It's not only in symbolic one. Here it is numeric methods as well. Okay, so make yourself super comfortable, and this is going to help all of you. Okay, so who
Sandeep,
help
how
me?
do we know that which algorithm or which equation or the function we need to use for to solve a problem actually? Do we have any
Good,
reference or linkage or something like that?
good question. Good question. So, like for example, like this, right? You're given 2 data points. Okay, you can draw a line. Now you're given 3 data points. Okay, there could be 2 situations. One, there is a curve going through them, or there is an error in the data and there is an approximate line going. So you don't know whether to go with a curve or whether to go with a straight line, right?
Yeah.
Okay, and then let's say there could be many more cases, right? So many more, infinitely many cases, and it would be impossible to figure that out. Okay, now one is, we call that validation. Okay, validation. What you do is, whatever data set you have, okay, split it into 80%, 20%. Okay, using the 80% data, you build multiple models. You build like 5, 6 more. You assume that, okay, maybe there's a curve, maybe there's a straight line, maybe there's something else. So you build all of those and check whether how they are doing on the unseen data. Okay, so this is the standard technique to figure out which model is doing well. Is it quadratic? Is it like a plane? Is it like a cubic equation, like 3rd degree equation or 4th degree, or it's like something else? Okay, so this is the only way. Okay,
Okay.
I'll talk about this much more. This is a very deep question, and yeah, we'll talk about this much more details.
What do you recommend from math perspective, right? To understand, because we all forget, right?
At least, yeah, those equations we already forget. Ranveer is right, actually. It's quite long time we studied maths. Yeah.
So what
I know.
What do you recommend? At least we should, refresh our memory. I know, equation, linear equation, algebra, which I
Yeah.
heard. But at
Okay.
least, what do you recommend, from your experience? That
I recommend that whatever we are doing in the class, do it by yourself. Okay, that will force you to recall all the ideas. Okay, and I mean, if I ask you to go and read linear algebra and give you a book, I can guarantee that you'll be derailed and lose your interest. Okay, so what I'm saying is that whatever I'm going to discuss in the class, that will be more than sufficient. You don't have to, the way you should do is that just try coding what we are doing. Okay, trust me. This is like a fairly advanced thing from the machine learning perspective, and this is more than enough. So Ranveer and everyone, my question and simple question to all of you is that, what are the parts that were not clear? You can tell me now so that I can try to be either slower, try to be more descriptive, try to be give more examples. So you help me understand what can I do because I honestly speaking, it is very easy for me to tell you and give you a book right now. And just like everybody else has done in past, that would only shift, that'll only shift the blame from me to you. I can always tell you that, hey, you did not finish that book. That's why you're not able to understand anything in the class. Okay. But the truth is that is only for blame shifting. And I don't want to do that. I realize that none of the books are doing justice. Most of the maths books, when you see the linear algebra book, it's like, I've gone through like most of the linear algebra book. They have made simple things super complex. And whatever I'm discussing here is what is needed, honestly. Okay. And like the differential calculus, there's like people say, oh, go and read that book. No, not needed. Not needed. All I'm asking is, all I'll do is that, like, for example, I'll give you this example, right? So I've interviewed like PhDs of maths. When I ask them a simple question, what is y equal to x square, dy by dx, everybody tells me 2x. Okay. The math graduates from the UCLA and everywhere. Like I must have conducted like probably 100, 150 interviews so far. Everybody can tell me this answer quickly. When I ask them to derive it, when I ask anybody to derive it, very weird part is that not only the people from India, but people from every country have just memorized it. Okay. They've forgotten, or they did never study the chapter where dy by dx is defined and limits. Okay. So hardly 1% people are able to derive it with first principles, right? Increase x a little bit, do this, and so on. Okay. Now, when I ask people to write a function to differentiate another function in Python, okay, only like 1 out of 200 or 300 people have done it. 1 out of 200 people, yeah, is able to write that code to differentiate. It's a single line code. Okay. And even those people who went and studied the entire maths book given by the teacher and professor of machine learning to finish the calculus, even they themselves could not code it. And this is a very surprising thing, because even if I give you the book and you finish it, still you won't be able to apply it. Therefore, I do not have too much faith in the maths book right now. Okay. So my request is, help me dumb it down. We have all the time. Don't worry. We have all the time. I can stretch it. I can stretch my classes. We can move the time to a little bit more. But I would request everybody to give me their full attention and stop me from moving fast, and help me figure out how can I explain things better, so that you can have that wow moment that, okay, whatever we studied in childhood, that's actually of use now. And this is all obvious to me. Okay. Yeah. Ranbir and everyone, it's a humble request. So if something is not clear, it's my mistake and I want to rectify that.
So no, making sense, Sandeep. I think BB agree. I think, maybe before we get into coding, my recommendation, and then everybody can chime in, if we can just, talk about, the calculation, the maths equation as you started, I think, so this is a, 3D equation. This is how we're going to solve first, because as we told, we forget, right? We have to be refresh our memory. It's been long time, that we are in touch with maths and all. So maybe before we get into coding, we can just talk about some sort of maths equation. This is how the first equation, second equation and all, and then we can get into a math, kind of coding. Maybe that's what I feel, but other can also chime in.
Okay. Okay. All right. So at any point of time, I request everybody that you should not have this mindset that, oh, just because I missed yesterday's class, that's why I'm not able to understand it. Okay, even if you did not understand previous classes, please stop me. Okay, because the chances are that if things are not clear to you, it won't be clear to other people. Okay, and I know that like connecting the dots is the hard part. You know, we studied equations, x plus y is 10, x minus y is this, and we can just do it quickly. But connecting the dots is hard. Okay, and I mean, even it's hard even for me. Okay, every day as I study the entire thing, I think about like probably everything, and then I realized that I have not, I did not understand really simple things. Okay, for example, how is the temperature in large language model defined? There is a temperature argument. If you have to code it yourself, how would you do it? And those kind of things. So I mean, and like really simple things, but they become complex. Like for example, the gradient descent algorithm. It's a pretty simple algorithm, and I'll show you how to get it done in Excel sheet. Okay, and it has taken me probably 10 iterations to do it when I coded the gradient descent first time. First time when I learned gradient descent, I did not know how it's being done inside the computer. And it has taken me a fair amount of time to simplify it. So connecting the dots is fairly hard. Okay. It's naturally hard. Okay. It's naturally hard. Our brains were designed to survive and then do the normal prediction things. We have, to build the tools for prediction and to predict that is essentially a fairly hard thing. Okay. So whatever we are doing, though it would look pretty simple, but implications are hard, are big, as well as connecting the dots, like the math fundamental that you carry, connecting that with the math, the math and coding that we're doing right now would take a bit of time. So stop me so that I can help and give you more examples and do that. All right. So everybody was able to do the two equations, and just now I gave an example of 3 equations where we had three equations and we have to solve for x, y, and g. So that is clear to everybody, this process that I walked you through.
Yes, Sandeep. So just one feedback from my side, right? I mean, what I noticed is that, right? I mean, solving an equation, a quadratic equation by hand, right? Actually, I'm used to all this, so I mean, probably, I can understand all of these, right? I mean, three variable equation, 2 variable equation, solving all of them. As you said, connecting the dots and putting it on the code is where currently I'm struggling, right?
Yeah.
First thing, and then the second thing is I have a basic knowledge on Python, and then I've used right, I mean, creating data frames and then doing all that, right? And then everything on Python is a function, trust me, right? Even we have NumPy functions on Python to solve equations. Probably that is where, right? I mean, and then if you ask me to write down that function and how that function works, yes, that's where the real struggle comes into play.
Yeah. So yeah.
Probably I guess those functions has made us lazy.
Yes. Not lazy, not lazy. It just keep your interest going, right? So the general strategy is to use the tool, inspect the tool, then figure out how to build the tool, then figure out how to build a better tool. Okay, so you start with starting to use the tool, when to use, then starting to observe how the tool is working. Then you open the tool and try to look at exactly how it's working. Then try to copy the tool and build your own tool from the scratch. And then you come up with a better tool. Okay. And that's the truth about each and everything.
Got
Okay.
that.
Yeah.
Yeah, got that. Okay.
Okay, so I mean that's the level, right? I want you to go through these phases and just struggle with the code. It's completely okay. Just don't think about the struggle. Just think about solving things, and don't stop at the struggle. Struggle is the good thing. That's the muscle pain you are getting. Okay, that's the muscle pain you're getting. Don't
Right.
stop there.
Okay.
And it's a good pain. It's a good pain, and I mean, just work through it. And again, the core idea is that don't memorize anything. You don't need to memorize anything. Nobody's going to ask you the formula for solving two equations or the slope and everything. Nobody's going to ask you. Instead, you should know how to derive it. Okay, you should know how to derive it, and that's the most important part about this. And as of now, I pity those people who hire candidates based on the definitions. Okay, because you cannot build products, you cannot solve hard problems if you do not understand how things are happening underneath. You can talk about it, but you can't solve the problems. Okay, and therefore my humble request to all is work on these problems. These are hard, but they make you a different person. They change you forever, right? These are something that we have done with the back of at the back of our hand. We have solved these equations, but writing code to solve the equations has been fairly hard for me. Okay, and I remember like when I was at Amazon, and there was a company named some Streamoid or something. They invited me for the discussion, and they asked me to solve equations using a code, and they gave me 50 minutes or 1 hour, and I solved it. The only problem was that I did not solve it the way the guy wanted, so he didn't like it. But my strategy was using recursion. Instead of, there are two methods. One is Gaussian elimination and other recursion. I use the recursion strategy, and people don't use recursion strategy that often. Okay. All right. So coming back to it, I would, it's already 12:30. All right. I would
Sandeep,
want.
may I interrupt you for a moment? I mean, I'm sorry. I mean, for me, I would be very vulnerable because it's a long time back when I studied mathematics. So it's quite hard, as Ranveer also mentioned, to recall everything and connecting the dots as well, right? And sometimes what happened that when you are working with those problems and if you got stuck, you need help. So
Yeah.
maybe a kind of live channel or something can help where we all can discuss those problems. And if somebody is stuck, other person can
I
chime in
think
and help,
it's
right?
completely okay to, you just drop a meeting link saying, hey guys, I need help on this. If anybody's around, can you join the link? Okay, it's completely okay. And it's also okay for you to just create a Discord channel or something where people are quickly available as compared to the WhatsApp one. Okay, so it's completely okay. I think you guys are going to be together for next 1 year, almost 1 year now. Okay, and therefore it's good to establish a good relationship with each other. And it's a great class, and things are going to become easier than this. Okay, and they're not going to become harder. Okay. One more thing, you might wonder that why am I not teaching each and everything about Python? Okay, here. Okay, so you might say that, hey, you are not teaching us, how to inherit, how to do this, do that. The truth is that nobody asks that thing anymore in the interviews. Like the way people used to ask in Java that how to inherit, what is inheritance versus composition, what is a private class, how do you define private, this, that. Those kind of questions are obsolete. Okay, people don't ask it. What people actually would be asking you is how to solve a particular problem, how to get this thing done. Okay. And as a data scientist, as a machine learning scientist, you guys are expected to solve these kind of hard problems. Okay. So that's why my honest focus is going to be on problem solving, specifically problem solving around machine learning. Okay. I'm not a big believer, and good part is that great companies would never, also will not ask that memorization questions like, tell me the definition of machine learning. Nobody asked that thing. Okay. So yeah, I would, can you guys, it's already 12:30. You have 1 week. Can somebody code this? Okay. You know how to solve it using pen and paper. And the process I outlined, right? The process was this. Okay. The process was this, right? First, we have 3 variables. We converted into 2 variables. Then we converted them into single variable. And then once that is solved, we found the second variable. Then we found the third variable. And there. Got it?
And it can goes up to n variable as well, number of variables.
N variable. So you can have here, if let's say we had x plus y plus z plus u equals 100 and x plus like that, right? That got converted into 3 variables. We eliminated u, then we eliminated z, we eliminated y, then then we found the value of x. Then using the value of x, we found the value of y. Using x and y, we found the z. Then using x, y, and z, we found the value of u. Simple. So if let's say I have to write the code here, this is how it's going to look like. Okay. So if length of, I'll just say equations instead of lists, we'll just say equations. Okay. If length of equations, okay. If length of equations equal to 1, then, right, find the value and return. Okay, so you can say return, if length of equations is 1, so it'll look like this, right? It'll look like A, comma B, right? Okay, so we can return B divided by A. Okay, so no, it'll look like this. It'll actually look like this. Because equations are many, so we are saying the length of equations is 1. So we pick the 0th equation, or you can say equations 0, and it'll return this. Okay, else. What to do in case of else? Okay. Eliminate the last variable. Okay, how would you eliminate the last variable? Everyone? So we will go for equations for I in range, second equations, or we can just say I in range, or can just say for, okay, we'll just say first equation we have picked aside. Okay, we have said equations 0. Okay, we kept it aside. All right. Okay, this is my first equation, and all the equations, right? The next equations, we just saying equations 1 onwards. Okay, we pick the next equations. Okay. Now what we do is we basically, to eliminate the last one, what do we need to do? What do we need to do is we need to make their coefficient equal, right? How, like the law, yeah, last one we are going to do, correct? Say, for example, this one, okay, this one. So what we'll have to eliminate this value, correct? We'll have to eliminate this value. Okay, and how would you eliminate this value? By making this and this equal. Okay, how would you make this equal? By multiplying first equation with this value. Okay, so let's say, all right, let's call it what do you call this value? Okay, we'll call it last coefficient equal to last coefficient. There is a last coefficient of this one, last coefficient of first equation. So we'll say first equation, okay, we are saying -2, correct? From the last, we picked this one. Okay, now this last value is going to be how much? The next equation, -2. Okay, so we are saying, let's say if this was 2 and this was 3, if we multiply first equation by 3 by 2, okay, 3 by 2, which means LC2 divided by LC1, that's our multiplier, okay, and we multiply the first equation with these and subtract from the second equation, right? So we, right, multiply, okay. Okay, so our next equation is going to be next equation multiplied with multiplier. That's it. And subtract the first equation. That's it. Now this is our new equation. Okay, we'll call it new equations equal to empty, and we will just add this new equations. Okay, that's it. And once you have this new equations, right, basically you just keep going like this. Once you have this new equation, so this new equation, and yeah, one more thing you have to do is from this new equation, what you have to do is you have to remove the thing that became 0, right? You will say from beginning till -2, okay, and the last column. Okay, so we basically just all right, that's it. So we said that go from beginning till here, but don't include the last one, because last one we have made it 0, correct? We have eliminated that. So that's it. So from the equation, one variable got eliminated. And similarly, number of equations will reduce by 1 because we are going from second equation onwards. And that's it. And then once that is done, what you do is, okay, we'll say solution equals solve equations and just ask it to do new equations. Okay, these are new equations. All right, so I just did the new equation. So we got the solution. Now we got the solution, right? Now what will we do use this solution? Okay, in the first equation, we will put the solution and compute the last one that we had eliminated here, and then append that to the solution and send it back. Okay, so now put solution in first equation. Okay, first equation to find the value of eliminated variable. Okay, and once you have done that, then append newly found variable, newly found coefficient, right? Coefficient and to solution, and then return solution. Okay, that's it. This is my method. Okay, so what you have to look at it is, one is go through either my way, it's called the recursive way, or you can do the Gaussian elimination. Okay, Gaussian elimination. So take a look at Gaussian elimination. You will get a quick picture about how does the Gaussian elimination work, and then try to do that. Okay, so just search online for Gaussian elimination method or solving equations. Do at least 3-4 exercises by hand. Once you get that feel of solving 3-variable equation, then you will get a feel of solving the algorithm. Okay, but do it mandatorily. Okay, do it mandatorily. I would want everybody to just sit down and solve it. Okay, because this is one of those hard questions that people ask in interview. Okay, and if you can solve it, I can guarantee that you will be able to clear almost every interview. Okay, and yeah, and I mean it. Okay, so sit down and solve. Okay.
I had a question. Why did we check the length of the equation in the first if?
This is the tail recursion. This is where it ends. Okay. See here, for if let's say there are 100 equations, this method will convert them into 99 equations. Okay, right? If there are 99 equations, this will convert them into 98 equation, and then again call it. Okay, so every time one variable is getting eliminated, a number of equations are reducing. One column is getting dropped, one row is getting dropped. Okay.
Okay, and the process we are using here, is it Gaussian elimination or regression?
This one is recursion.
Oh, recursion.
Yeah, this one is recursion, and yeah, I haven't seen it other people using it. I find this simple to explain. That's why I have put it forth. Okay, both have similar complexity, so it's okay to code either this one or the Gaussian elimination. Okay, so go through Gaussian elimination, but try solving, say, 3-variable equations by hand, and you'll get a clear picture. Okay, this will brush up your memory. Just search for, say, online exercise, or just put some equations, right? As long as the equations are not like this. Okay, let's say somebody says x plus y plus z equal to 10, and then says 2x plus 2y plus 2z equals to 100, right? This is inconsistent. They can't be solved because x plus y plus z is 10, x plus y plus z is 50, right? If you see, divide by both sides by 2. So basically, this is unsolvable. So you can also put down these coefficient by yourself, like randomly, and try solving by hand and make yourself comfortable. Okay, once you are comfortable, then you think about how can you make computer do it for you. Okay, let the computer do it for you. Okay, so there basically instead of looking at my method, okay, I would want you guys to code it by yourself. Okay, think of your way, think of your strategy, and solve it. It's okay to research, it's okay to go on internet and spend a good time on this. Okay, but do it. Trust me, it'll be very, very useful to you. Okay, all right. All right, so we will continue this. This is a pair. I mean, I decided to start it today. Okay, but this is not the end of it. This is the beginning. Okay, this is the beginning. There'll be a lot more things coming up. So yeah. Okay, so yeah, I think that's the only way to learn machine learning. There's no better way. I could make you memorize everything, and then you will feel that you have learned everything, but then you'll come back and say, hey, I'm not able to clear the basic rounds. Okay, So I want to.
Sorry. So you said you started new, if I go back to syllabus, so is it after Python? Yes, getting into this.
Yeah. So I had actually decided that we'll merge the maths and Python and everything together. Okay. Yeah, I think that's the only way to learn it, because these are not isolated things. Okay. These are not isolated things, right? Just learn the syntax quickly and then start getting to solve the problems. Learn syntax quickly and solve the problems. That's the way we are going ahead. Okay. And yeah, more and more problem solving is needed. And yes, I think that's the best use of your time. Okay.
Sandeep, this is my first class, so
Okay.
I just want to understand, apart from the session recordings of the previous sessions, what is something that you recommend to cover to cope up with the previous?
See, previously what we have learned so far is essentially the Python constructs. Okay. And yeah, and we spend good time in solving different kind of problems. Okay. So other way could be these notebooks are good. Okay. These notebooks, if you see, I put them in this, you can see my this, I think here, I'll just give you this. So you can quickly go through this one. Okay. I have put them in time-wise manner, so you can quickly go through it. Okay. Okay. So there are quite a few questions that we keep doing as part of the course. I think that you can start with those questions. How comfortable are you with Python?
Not much.
Not much. Okay. Okay. It's better. I think it's better just get to the coding. So yeah, I think my suggestion will be just start today. Try solving the equations problem. Okay.
Yeah, I mean, I have a background on the digital analytics, so sort of
Okay.
JavaScript or jQuery kind of done, but not Python.
Yeah, that's okay, right? You'll be able to handle Python. Nothing to worry. Okay, you'll be able to handle Python. Okay. And yeah. So I mean, if you are comfortable with doing it in JavaScript, do it in JavaScript. It's completely okay. Okay. Right.
And then the nodes in the drive that you were showing in the screen, how?
I'll just commit to the repository. Okay. Just clone this, clone this repository and just use it. Okay. I'll just commit it before I forget.
Sure,
okay. And all right. Untracked file is this June 22. This is the one, right? Okay, I also did hello today, hello.py. I'm very bad at writing the commit notes. Okay. And there was my teammate who used to write like poetry in commit notes. Okay. All right. So let me see where we are. I don't think you need Mambox results output. Okay. All of that is not needed. Or should I just add it just in case it's needed? Perfect. And okay. Yeah, done. Okay, so take a look at those notes and yeah, reach out to me or my team at any point of time when you are stuck. Okay, just drop a message in the WhatsApp group. Probably
Yeah.
anybody.
Sure.
All right, perfect. And yeah, so if you're comfortable with JavaScript or anything, then Python will be a piece of cake for you. Okay.
And Sandeep would love to know your comment, right? I mean, in ML and AI, we are going to use such a huge data, right, to learn our models, and
Yeah.
there will be copyright issue as well. Because so how we are going to handle that thing as an AI expert? Because it can come like you are using some data and somebody comes to you and say it's copyright. Why you are using? I'm going to fine you.
Question is that very good question. Question is, can somebody figure that out from your model?
May or may not be. I mean, it's not that easy. Yeah, of course.
Exactly. Exactly. So if you are given two data points, 1,2 and 3,4, and you have drawn the line, if somebody sees your model, which is your line, can they say that which data points did you use? No, right?
Yeah.
So honestly, it's very, if your model is properly built, people can't figure out from the model. But if the large models have a habit of memorizing data points. Okay, they carry the data points. Okay.
Yeah.
And because of which people can reverse engineer and figure out what is the data on which your model is trained. Okay. And that would be the problem. Okay. So there, I think the case, if you take a look at the OpenAI versus that newspaper, right? New York
Yes.
Times.
Yes.
There was a case, right?
Yeah.
So yeah, they basically kind of memorize, but I think those things are nice to have. When you become that big, only
Yeah.
then people will sue you. Okay.
Yeah,
And
definitely.
those are nice problems to handle.
Yeah.
Okay. Yeah. And till that point of time, you don't have to worry. Okay.
Yeah.
So yeah, don't have to worry. Okay. Copyright issues are great in the corporate, unless you are a lawyer. You don't have to worry about that.
Okay.
Okay. And yeah, for now, I think we will see, right, as a general tendency of engineer and a hacker, the tendency would be, we'll try to see what's possible. We'll try to see how can we solve problems. Okay. And we'll seek forgiveness rather than permission. Okay. Yeah. If we end up making a mistake. All right. Bye. Have a good day.
Bye.
Sandeep.